Welcome to the MTD Technical Corner. Today we're going to be discussing eye machining, the revolution in CAM with Ben. Welcome to the MTD Technical Corner, Ben.
Hey, Joe.
Eye machining, the revolution in CAM. What is eye machining?
So eye machining is our high-speed roughing strategy. So it's fast metal removal, getting rid of the majority of the stock as fast as we can.
So it's a roughing strategy. Now, I would assume, and please talk us through it, that a lot of the time savings come through roughing, and this is the importance and the main USP of eye machining.
Yeah, a lot of people can concentrate on the finishing strategies and things, but the roughing is the majority of or the bulk of the material that's going to need to be removed. So being able to get that away fast is where you're going to get all your time savings in the job.
So talk us through it in more detail and from a technical perspective.
So eye machining is sort of a two-stage process. The first stage of it is a morphing toolpath. So you've got obviously a stock shape on the outside, going down to our shape as you can see on here. Yeah, so we morph from the outside shape to the inner, maintaining a constant chip thickness. So not a constant step over, constant chip thickness. So we're constantly varying the speed or the feed rate, should I say, determined by the contact angles as it's cutting.
And is this done automatically?
Automatically, yeah. You tell it, so 3D eye machining, as you can see here, we are telling it to cut the entire target wherever there is stock. It is doing all the deep cuts first. You can see full depth of cut using the full flute length, and then it will come up where there's stock left and create a skull on the component.
So this is morph machining?
Morphing, yes, it's a morphing toolpath. The second stage of eye machining then is the technology wizard. So the wizard then takes in data from the machine tool, so we know the power at the spindle. It takes in all the data from the tool, takes the data from the material, and then it will produce its own depths of cut, speeds, feeds, and all the step overs and contact angles.
This CAM strategy, is it unique to SolidCAM?
It is, yeah. So it was developed by SolidCAM themselves, released back in 2010. So it's been with us for a while. Still, our sort of big focus, our big USP inside SolidCAM is the high-speed eye machining.
So effectively, Ben, this takes care of everything pretty much automatically once you give the machine tool the component details. But what happens if you've not held the component securely, or your tooling is sticking out quite a long way and you might experience some vibration issues?
So the software can account for that. We've got a machining level, so it's the material removal rate. So although eye machining will calculate all these speeds, feeds, depths of cut for you, you've then got a slider bar from 1 to 8 where you can slide down, up and down that scale, which will bring everything. So you keep using still the technology of eye machining, but just slowing everything down a little bit. Still getting all the benefits of sort of tool life, less pressure on the tool, on the spindle, and things like that. Still getting that high material removal rate, just at a sort of reduced rate instead. So if you held it on a casting or held it quite flimsily, for instance, or like you say, long tool sticking out, the program has got the option to dial that down a little bit.
Okay, so let's start discussing some of the time-saving benefits using eye machining, starting with cycle time reductions. On average, what would you expect a typical cycle time reduction to be using eye machining?
So on average, we're boasting up to 70% cycle time savings. The harder the material, believe it or not, the better it is for eye machining. So you can get up to sort of 90% cycle savings cutting into titaniums and harder steels, but 70% is roughly the sort of average marker that you'll be gaining.
Well, that's massive.
Yeah,
It's game changing effectively.
Big cycle time.
Now, you mentioned cutting tools. We've mentioned cutting tools if they're sticking out a long way to get accessibility or whatever the case may be. How is the cutting tool life longevity?
Please come inside.
Benefits of that financially?
Yeah,
Please come inside. We have to start.
That the cut is a lot nicer, a lot kinder on the.
Please come inside. We have to start.
We're also using the full flute length as well. So if you paid for all that carbide, instead of using just a section of it and then creating a notch in the tool where now you can't use the tool again, you've got all of that flute length that you can use. So why not use it all? You can see here full.
Please come inside. We have to start.
So is that part of the strategy then, to use the full length of the cutter?
It will, yeah, it will go as deep as it can with the flute length. Obviously this got a bit more flute length to go, but the depth of the part obviously is not the same length as the flute length. But
Please
the idea
come
behind
inside,
that is
we
get as
have
deep
to
as we
start.
can, with that tool.
So the engineering, or the engineer plays a big part in this by choosing the correct tools for the application. So this is effectively a tool to enhance the productivity for free access machining.
Yeah, exactly. It's not there to replace the engineer. It's there to give them assistance and a tool to use to increase their productivity and to increase obviously the efficiency of the tool path, but also tool life on there. So decrease the cost of purchasing new tools. It's better for the machine tool, less pressure on the spindle bearings and things like that as well.
So it also gives your machine tool better longevity.
Yeah, definitely. Yeah.
Now, Ben, this sounds absolutely fantastic, but for people that may be watching this technical corner and think that it's too good to be true, can you prove to them that it isn't?
We can, yeah, and we often do so. If anybody wants to send us a part or they want us to come in to their facility, we'll happily program a part using iMachining. We'll cut it, we'll run it on a machine. We'll take the challenge and we'll prove to you that we can save you cycle time, but obviously we'll save tool life as well.
Ben, an absolute pleasure. So there you have it, over 70% cycle time savings with the revolutionary
Hello, welcome everybody. This is my presentation, and I want to inform you, because there are the presentation slide numbers. It's totally 43. So when you check that it is 43, it's gonna finish. I think it's gonna motivate you every slide. Because sometimes nobody knows when it ends. It's good that you will know. So it's good that everybody fly to Istanbul. So when I say where is Tekyaz, everybody know. But the nice thing, at least from my point of view, we are right in the middle of the world. And this is not a coincidence, because also we are where two continents meet. Do you have an idea? Here are people from Europe, from Asia. So this is the place where two continents meet. Actually, you can see the Europe, it's Turkey. We are now in Istanbul. This is going to be a kind of a geography lesson for you, because maybe one day you join a $1 million show on a TV. Somebody asks you, and you know the answer. You call me. Thank you, Ilker. I am the winner. So this is my office view. Almost, let's say, when we drive at least 10 minutes, let's say, for breakfast. But it's in Istanbul, so today you will see this place on the boat show. It's good. Another lesson now. As you see, there is the Black Sea, and there is two channels, two straits. On the top, it's called Bosphorus. And at the bottom, there is another one longer, it's Dardanelles. So as you see, two continents do not touch. They very come close, creates the Bosphorus Strait and the Dardanelles Strait, and it's not river, it's just a strait. Black Sea joins Aegean Sea. So now you understand, this side is Asia, and this side is Europe. You see the Bosphorus Strait again and again. So when you go back, you know iMachining, you know SolidCAM innovations. At least everybody knows now Bosphorus Strait. Asia and Europe. Not finished. And this is called the Golden Horn, and all the attractions, the old city, is right in this place. Because in the past, when you hear some history about Constantinople, Byzantians, when they are talking about Istanbul, Istanbul was only here, this place. All the rest, we say, Dutluk, just trees over there. Okay? So, the whole Istanbul history is all around here. So when you go to Old City, in fact, you are going to the old Istanbul, and there you will see the walls around here. So these walls were to protect the city. So today, again, the boat will be around this place. So when you recognize the nice palaces, everything, now you know the story. And the sultans were living in Topkapı Palace. This is Topkapı Palace. Think that you are here, watching the strait, the ships are coming, going. So this is an amazing Topkapı Palace here. And Hagia Sophia is here. So you can spend one full day, amazing, in this old city area. And you can be a guide now. So welcome to Turkey. Thank you, all my friends. It's really a pleasure. I think it's only one time in a life to welcome you in my country. Thanks for that. Thanks for this crowd. You make it amazing. Thank you. So as you see, we are a SolidWorks reseller, a very strong SolidWorks reseller. We started with SolidWorks. We are today 200 people working for SolidWorks. We can say that there is 450 resellers around the world. And when you check the top 15 resellers, you will see the name Tekyas there. It's not so common that a software company is for 200 people. This is the place where we can win against at least SolidCAM GmbH, in numbers at least. So we have 5,000 customers of SolidWorks, and these customers' main pain is digitalization. The first thing they ask is not, I want to cut this part, I want to make a 3-axis milling. No, they want a full automation, full digitalization from design to manufacturing. So we don't care any CAM software if they can cut the holes much better, much faster, the surface is much better. Because we are the only vendor in Turkey that can offer a fully transformation to digital environment with a full, strong support. Don't forget that. This is the big difference. You can get any CAM system. You can maybe cut the hole faster, but if the information is wrong, only the user is happy. Running in the company, see this hole. What a great hole I cut. Thank you, but sorry, it is the wrong hole. So communication and full digitalization is important. And for this, you need a team. But not a team of people. You need a happy team. So we are certified. In fact, I didn't certify it. My people certified themselves. They say that we are so happy to work in Tekyas. It's a great place to work. So with happy people, you always win. Of course, we have a core SolidCAM team. As you see here, you see Tekyas core team. Of course, we have a sub-reseller network. Maybe Tekyas SolidCAM team is 25, but when we add all the sub-reseller network and partners, we can easily double our effect to the market. In Turkey, I guess also in your countries, we have very important industrial regions. But our difference, we are not a company trying to sell software on the phone or from just one main office. We are locally very close to our customers. So all these regions, we have offices, we are training, we are post developers over there. So we believe that there are independent companies with full initiative, creating their own support, even talk the language of the customer. Because even when you have Turkish, we have some dialects. When I go to Konya or Kayseri, different states, I stop talking and my people talk. They can easily collaborate. So with this short description, I believe in our success there is three key important pillars. The one is the software side, of course, SolidWorks, SolidCAM. I believe they are best of both worlds with a seamless integration. This is unique. It's not easy to find best of both worlds softwares and have really good solution. So there's a good thing to believe. The other one is partners and tech, as I mentioned. Yes, TechYaz is a good support partner, but it's very important to think globally as Turkey or globally as a world, but find ways to act local, which our partners, sub-reseller network, do that, thanks to them. And final, and not least, the most important thing is our customers, our users. So instead of giving a big importance to companies and business owners, maybe we give much more importance to our users. Because we see that our users, most of the time, are the king. They are the real decision makers. Everybody wants to use the software they know. They feel that they're powerful. They feel that they get support. So we don't forget those people. We give them full support, training, continuously have relationships. You will see how we do that. And of course, all users were all once in education institutions. So we meet them at the university level, at high school level. You will not believe, but we even have customers in primary level. So if you come back to SolidWorks and situation in Turkey, I can easily say that SolidWorks is the de facto CAD standard of Turkey. No other CAD system. First, they are the only software invested for Turkish language. All CAD systems are in English. So they invested. So you go to your customer, look at his eyes, is there any software really care about your language? No, it's SolidWorks. So when it comes to SolidCAM, it's the only software that has an official Turkish version, official Turkish help files. No other companies invest that. TechYaz continues to make all these translations, create all these big effort to do that. So if you are a student, even if you find a piracy copy of SolidCAM, you can reach that Turkish language help files, installations. You don't need anyone. You can do it self-service. And, okay, so EDU, 80% penetration. I can easily say that almost all universities using SolidWorks. All universities that have a CNC machine, the natural choice is SolidCAM. And let's look at how we see SolidCAM. For us, is it just always holes cutting parts? No, for me it's not. I'm a guy coming from CAD. So I have a different perspective. So this is my perspective. For me, a demo is just 1 minute. I am on an elevator or in a car talking with the guy and show the video. I said that in our software, you don't need to learn anything. I prepare everything for you. Just drag and drop for the pockets. All the libraries going to be set by us. So we know your tools. We know your all detailed parameters. So by just drag and drop to your pockets, you will have automatic CAM for you. So this is not a CAM system. I am creating, building an automation for you. So when you leave your company, all the people after you will make a statue of you because they will find the library of calculations. By just drag and drop, they will always say, thanks to Mr. İlker, thanks to Mr. İlker. For the holes, you know, you go to the holes, you turn it. And so this is very easy to replicate because all SolidWorks sales guy, they are CAD guy. They don't want to talk about too much about all these CNC details. Just show this. You are doing CAD, in just a couple of minutes, you create all the toolpath by dragging, dropping. You don't need to enter any menu. Yes, somebody did it for you in the past, but now you don't have to do it every day. And then report. Everybody loves report. Without a report, you cannot show anything onto the shop floor. Just show the report, it's done. This is, from a CAD perspective, what's going on in the shop floor. I just drag and drop, give the report, and it's done. This is how we prefer to present our solution in the first look, let's say. And we support this idea with partners. As you see now, we have totally seven resellers. Some of them were from our competition. They just say that we cannot survive with these competition softwares. Let's come back to SolidCAM ecosystem. As I said, they have their own offices. We have a really strong relationship with them. We visit them. We discuss their market issues. Everybody has their different issues. But at the end, the core team is helping for all. So this is the team for technical, all our sub resellers, and we leverage them, and they are also tracked by an electronic system for customer success, to understand how much time we spend to support our customers. We have KPIs for that. For example, today, we sometimes feel like we are a pizza service station, because customers call me, hey, Mr. Ilker, you promised that you were going to solve my problem in 10 minutes, but it's 11 minutes now. Are you going to send me a free pizza? Because we really set our goals so high. We said 10 minutes, no more than 10 minutes. Of course, post-processor development is another issue. Here, of course, we have to thank to SolidCAM team, the Serbian team. Serbia is very close, by the way. By just 1 hour flight, they can come to Istanbul. But it's not just helping us, also they educate us, hands-on training in front of the complex machines. It's great, amazing. This is the thing that I am always telling. There is never no from SolidCAM. There is a complex machine. We see it as a challenge, but SolidCAM is also seeing it as a challenge. The phone is like this, oh, great machine. Maybe if I come, we can learn together. So this makes it happen. So some typical customers in Turkey, I want to show you. This is a machine builder. They have 10 seats of SolidWorks. But for us, the problem is full digitalization. We are not checking even any other CAM solution. From the beginning, they are using PD and PLM systems. There is the shop floor, there is the design department. They design very complex machines, processes, lines. But at the end, there is a shop floor. And this guy doesn't know anything about what they are doing normally. What we are trying to do, we want this guy to understand what he is milling. Because this guy is a smart guy. He knows that this hole is wrong. Maybe as a designer, you did a hole, but from manufacturing perspective, it's not so effective. So we have to make this guy contributing to the design department. How we can do that? With PDM, PLM systems. And with SolidWorks, SolidCAM integration. We don't give him a standalone CAM system. We give him a SolidWorks and SolidCAM. So he can interact, see the assembly, where this part is used, what can the efficiencies that he can report back. And when you look at this, it's a simple part. Any CAM system can cut this part. Not so complex surfaces. However, when you look at all the operations, there's a big operation for each host, for different sizes, channels. You have to add all these operations. If you don't have any connection, you cannot talk about any efficiency. Because any update coming from the customer, this is our power. Everybody should understand that there is no single CAM system that I can trust for that this digital continuity can happen. But of course, we also have mold makers. But it's not only mold maker. He is making plastic simulation. He is changing his design. He's visiting customers, offering some change in the design of the pipes. So all these ribs is a total solution. So without SolidCAM, I feel something is missing. Because my power is, no worry, Mr. Customer, we will have all the solutions in one single platform. And SolidCAM is the biggest part of it. And we have even customers, very big names. This video became viral because they were using other CAM system. After we did this benchmark with a tool company, they are making load cells. This is to evaluate the weight, but we use eye machining here. With eye machining, suddenly, 20 years expert of using another CAM system start to cry in front of us. I lose 10 years because of that. Another customer, when you see, is a machine customer. But then when we go there, we are just looking at it, hey, why don't you use eye machining here? If you make this eye machining, you will earn a lot of money. So then this discussion is not only design, also adding the manufacturing perspective. So what is this? This is a recycling machine. So we sell SolidWorks, all the PDM systems, and SolidCAM is the key for that. Because we win the heart of the customer with SolidCAM, but then they believe the full digitalization. Let's go back to the training. Training is very important, and we have to reach big masses. We cannot train everybody one by one. So we created a platform. It's called Turkey's online platform. On this platform, you can reach any kind of SolidWorks training, SolidCAM training. It's free. So we don't charge money for that. If you can learn the product, self-service, no problem. We even, with our partners in different local regions, we make some collaborations with industrial zones. So they teach SolidCAM to the teachers. They teach SolidCAM to users after the job. All these people are collaborating with us. Moreover, we have a special program every year we announce by leveraging the 60-day, 30-day trial program of SolidCAM. We offer everybody in Turkey, once in a year, free training. We tell them that, hey, Turkey, we are teaching you CAM. Anyone who wants. Or professional trainers will spend their time online to teach you. You can join 2.5, 3.3, 4.5 access, but even sub-resellers all support. So we all together make this happen. We every year train with these online technologies 1,000 people. So if I can train 1,000 people, maybe 2.5, maybe small, after 1 year, I see them around in the customers. We even have similar programs for high school level. This is a special program. It's funded by European Union. Altogether, we first time in the world teaching CNC milling, CAD, and CAM in one single platform, in one single course. Not only one part of the issue, the full. Moreover, we are the first pilot company for 3D experience platform to be used for education. What we are doing here, today in Turkey, we have 4,000 students join this platform. We ask all the students to be in this. We give them SolidWorks licenses. We give them, if they want, SolidCAM licenses. And we continuously track their success, their progress. We certificate them. In this platform, this Industry 3D Experience platform, we can quickly recognize if they are talented. Because when they receive the certification, there's a kind of gamification. We recognize them. For example, the guys around you, you see some red t-shirt people working for the SolidCAM event. In fact, there are some young talents from this platform. We just ask them to join this event and help around. They know SolidCAM. And of course, all these educations today controlled by more than 30,000 licenses of SolidWorks, 8,050 plus educational institutions in Turkey give training for SolidCAM continuously. Even publications, since 2004, 2006, Turkish books. You just get the book, maybe get a piracy copy, I don't know, and then you learn it. Don't worry sometimes, because we are doing volume business. We are not trying to sell some boutique softwares to make 10 licenses per year. We want to sell 1,000 licenses per year. Today, as Tekyas, we are selling more than 1,000 SolidWorks licenses every year. Do you expect me to train them every day? Impossible. So, with these trainings, what happened? You can make this test by yourself. Go to the LinkedIn. I did it. These are the competitor CAM systems. Maybe you can guess. I didn't write them. I checked how many people put the name SolidCAM globally, and how many people say that I know SolidCAM, or I don't know, mention it. For example, globally, there is 10,000 people on LinkedIn saying that I have some SolidCAM experience, 10,000. I check all the other customers, all the other companies. Yes, as you can expect, one brand is really high. But then I check a kind of percentage for Turkey. So when I discovered that all these education effort changed something. In Turkey, we hold 29% of LinkedIn users saying that I know SolidCAM. And checked it also for the other brands. Look at that. 6, 6, 10. So the average for Turkey maybe 7% of the global job market. But in Turkey, it's totally different. So this is a game changer. As you see, you can do it right now, tomorrow, for your country. And then I checked the Google Trends. If you go to Google Trends, it's very easy. Every day you can check it. This is the past 5 years, monthly search. Everybody in the world get up in the morning. Of course, they are in love SolidCAM. So they search SolidCAM. Where is SolidCAM training, something? And this is the trend. It's almost same. But then I check the most popular regions. Slovenia is number 1. Who is Slovenia? Is there anyone from Slovenia? Thanks to them. Bravo. You're number 1. But Turkey is also in the top list. They are also in the top list. Israel, of course, is there. And this is the map of SolidCAM now, the popularity map. So then I wanted to go deep down. I wanted to understand also the cities, because what I said, think global, but act local. And then I see that this is the capital of SolidCAM now, Konya. Konya is a city from Turkey. My customers in Konya, thanks for your 100% market share, because in Konya, no other CAM system really can succeed. Also, Kayseri is another very popular region. Bursa, again, Turkey. So as you see, when you act local, those cities really focus SolidCAM. There is again another city there, this Ljubljana. It's not from Turkey. Do you know where it is, Ljubljana? Is there anyone? I know, I learned, it's like this Slumdog Millionaire film, because I was watching again Galatasaray, again Olympic Ljubljana, and then I discovered what is this Ljubljana, if we can eliminate this team, and I understand that it's from Slovenia. Hopefully we eliminate, but thanks to them, they are still making really good things in Slovenia. I can understand that. So, another information for you, this is Konya. So, maybe in Istanbul, if you spend some time, you will see some whirling people, some spiritual stuff, dervish. They are all coming from Konya, very spiritual city. And for me, SolidCAM is like a god there. Everybody wants to know SolidCAM. It is so interesting. If you spend some time, when you say that I am from SolidCAM, you will get full of respect. And also when you see balloons online or anywhere around, again, think that this is Konya or Kayseri. So this is SolidCAM for you. Capital of SolidCAM, if you ask me. And so how we do that, we also do some roadshows. So we don't do a roadshow just in Istanbul. We go to the customer site. We go to all these cities where we are strong. Our people engage with the customer on site. We make similar events. And we also make sales there. Because we ask all these people to come if they want to buy. The best time is face-to-face. So Kayseri, you see Kayseri now. It's one of the capital. Also, we make events. This year, it was very nice, and all Somek family was almost in Turkey. And we make a great show. In this show, as you see, as you can expect, we have live cuttings, bolts, milling, and Swiss type, of course. But also these kind of events creates really good relationships. So this is again me talking too much, sorry. But customers really still, for 10 years I do the same thing. For 10 years I cut the same part. I didn't get bored to watch iMachining. But believe me, customers also didn't bored. They want to see us cutting iMachining parts live at the events. Every year I challenge all my competition. I say that on the phone. There is no single CAM company around us to make live cutting in front of you with something similar to iMachining, and they don't. They cannot do. So these kind of corporations created also some nice joint events. For example, GNC is distributor for Grop for Turkey and also Victor machines. So they invite us, we invite our customers and make similar events all together. And it's really very effective. So everybody talk about it. To keep it short. And of course, we are not just a show company. We make real business. How we do that? After we started Swiss Type, first we got a lot of help from Daniel team, Maria, they came us, they help us all these projects, as you see. But then we continue. It's a sustainable investment because SolidCAM is investing. They are now going to be the #1 Swiss Type solution, but which has the only software that offer digital continuity. When you say 5-axis, sometimes we always think that it's only simultaneous 5-axis. No, the biggest market for us is 3+2, because our customers are making big machines, and these parts has to be machined in a very big machines, precise cutting, and you have to deliver great post-processor to Konya, to Kayseri, anywhere in Turkey. It's not easy. Not everybody can do that. So when you do this, the network talks. Even 4-axis, when you cut these parts, everybody around in the industry comes to you. They even come and watch your cutting on customer side. Even robotic, we have colleagues that have good experience about it. These software companies call us robotic automation companies to get help from us. So with 5-axis, we help them to make this kind of cuttings every year. So for us, if you have any kind of milling machine in your factory, today with Swiss Type also, just call us. You don't need to spend your time around, because we have a solution, a real solution with post-development and everything internally localized, even in Turkish language or in a Konya dialect also. So finally, as I said, this is the secret. The main secret is the team. The technical support team is great. This is the people that you see now. But behind the scenes, of course, we fully use everybody in SolidCAM. Everybody in SolidCAM. So final words, slide 43. You know, a lot of things change. Economical crisis, SolidWorks sometimes change their decisions, 3D experience coming. But it's enough long for me. More than 20 years now in this business. I see many, many problematic seasons. But the only thing I believe is my team. When I look at their eyes, they have always the passion. Because we know what we do. And we believe ourselves. We believe SolidCAM. Also, we believe all the people around the world. You see how people say, yes, we can. This is so good, and this is something so unique. So we say that we are not pessimists. We will not complain about the wind. Even we are not optimists. We will not say that things will change, everything will be fine. We are not that kind of. Because we are not just interested in CAM business. We are committed. We are committed to CAM business. The only company committed to CAM. We don't want to sell our company. We want to solve our customers' problem. We are not interested, committed. So we are realists. we just adjust our cells and get the results. So thank you.
Thank you. There. Wow.
One
what
second,
an ovation.
1 second, Linda.
there is one
Linda, I
question.
have something to say first. So I learned today that Konya is the capital of SolidCAM. So I vote for Ilker, the wizard of SolidCAM sales. Who agrees? Raise your hand.
Thank you.
Ilker, wait, there's one question from Marco Les. He says, what software do you use to track support time and efficiency?
Yeah, we believe single data of truth. So we are using Microsoft CRM system. So we implemented any kind of technologies we need onto that platform. Thank you.
Okay. Hello, everybody. As this is my first presentation for today, I'm going to introduce myself. I'm Daniel Jurica, and I'm VP for Technical and Post-Processor Support. And it is clear, everybody here know that SolidCAM is the #1 CAM for the milturn and Swiss type solution, right? And of course, also our competitors knows about that we are the #1 CAM software in the world, right? Now I'm going to tell you 10 facts and features why this is like that. So the first of all, it's clear. It's integration. I don't know any CAM software integrate as much as we do, right? We are easy to learn and fast to program. This is the most important fact in CAM industry, right? Our amazing toolkit. It's a breakthrough. You all know about this. It released in 2021. It is the best tool management system in the world, 100%. And it is also a platform that will allow us to make even more things in SolidCAM in the close future. We're going to see that very soon. Our amazing toolpad. We have all solutions from turning to milling, eye machining. Our MCO cycles, they are predefined in our post-processor, give our users clear parameters that needs to be defined for specific programming. We have amazing channel synchronization for multi-channel machines. Machine simulation to simulate and verify our toolpad. Post-processors verified, always. Amazing technical support. And the last is the setup sheet. So let's go through quickly about each one of these separately. We are the #1 and still the only Swiss type solution within the SolidWorks. So if your customer have the SolidWorks, if he has in his workshop some Swiss type machines, we are the only one who can do it. The newest is that we have integrated into Solid Edge, right? And also Tiangong CAD. So this is another breakthrough in our integration. Easy to use, fast programming, fast learning curve, intuitive proven. Nobody can argue about that. It's so nice software to see, so many beautiful colors, it's so fast, so legit, so powerful at the end. And the most important, it's easy to use. And our toolkit, as I've said, released in 2021, it gave us tons of possibilities. I'm going to just count some of them because they are it was so important during our development that we ensure that we can support any kind of customer needs for the milturn and Swiss type machines. And one of them is definitely the fast configuration of tool layout. It is extremely important when you have a Swiss type machine to exchange the configuration fairly quickly. So this is allowed just by 2 clicks that you can just switch between two stations. This was amazing, right? Support custom shade katas. Any 3D model on the internet, you can download and just make it that it's a tool. Indexed revolvers. We always support indexed revolvers, by the way, but this time it's on a completely different level, more easy to manage. We also support any kind of face, axial, angular, and multi-cutter holders, making sure what is behind the scenes, how to output correctly code, planes and stuff, very important. And in 2023, I'm going to talk in the next presentation. I'm so honored to have 2 presentations in a row. We used our Toolkit engine and use these library possibilities and engine to allow users to define the fixtures. So something about the toolpath. We have a wide range palette of turning, C, Y, B-axis milling operations, including unique patented eye machining technology. Available only from SolidCAM ensures that every part can be optimally machined. There's endless capabilities in milling and turning, and we give the complete control over the x-axis. This is extremely important, positive or negative, rather that it's a milling or turning, and avoiding potential collisions with the neighbor tools. Also, of course, the polar coordinates interpolation, phase or radial, we fully support it. We make sure that whatever the customer has it on the machine, we support it through that as well. If the case that customer doesn't have the phase or radial interpolation cycles, we are going to anyway interpolate it. Of course, the customer is going to receive a longer G-code, but the end results will be great. Another, using special holders may sometimes lead to a potential and risky situation, and it's very important that you have a possibility to index your pod and approach your toolpath from a different C-axis direction. This will ensure that your part is correctly machined with collision-free. Supporting thread reeling as an irreplaceable method in the Swiss-type machines for precise machining of medical screws. And we have, for customers, in our post-processors, we always prepare the minimum list of MCO cycles. And for all the audience and also for the live streaming, what are the MCOs? Those are predefined cycles that it's not really connected to a toolpath, but it allows us to control some parameters on the machine, and like a process of the pickup, bar transfer, cutoff, and stuff. So we prepared the minimum list of parameters, what is necessary to program-specific sequence. So in this case, we have just a pickup cycle where we dynamically, through the machine preview, give a user possibility to dynamically see everything in the machine environment. Synchronize, optimize, and maximize productivity through our channel synchronization. Amazing product, without which none of the multi-channel Milton or ERA Swiss-type machines would not be even possible. We create a lot of improvements in that area in order to achieve that. We have channel synchronization and clash avoidance, which marks the operations that require some action, that guides the user through the pointed arrows, as you can see over here. And the system knows exactly what controller logic is and checks the possibilities of synchronization. And we take into account machine kinematics, axis sharing, and synchronization weight mark rules. This is extremely important, as it's not something that you're going really to crash machine. It is not crash, but clash. But we don't allow user to simulate or even to generate a G-code in the case that something is wrong in the channel synchronization. So you're not losing time generating a G-code, going to the machine, and then discovering that something is wrong with the weight marks. So we are preventing users to make any mistakes in ahead. We support 3 different superimposition modes. Axis can be superimposed over other axis, where a slave is following the master. Mostly this mode started, I think, in the milturn machine, but of course it is irreplaceable in the Swiss type, especially if you are doing the cutoff and you are doing something with chamfering. Every machine runs it, through the superimposition. It must do it. Without the superimposition, you are not a king of Swiss type, definitely. We reduce the machining time and stabilize the part machining by using the sharing axis and drive unit features. You all know these options. And of course, machine simulation. It's so beautiful. All the details can be catched here. The toolpath verification can be checked. We are making sure, providing full collision detection between machine components, workpiece, fixtures, tools, and holders, of course. Part transfer, simulating the cutoff, of course. And about the post-processors. For most of you, you know that post-processors is considered with the two files. One is the VMID that is behind the screen, and another is the GPP. In the VMID, we define complete structure of the machine and all related controller parameters, while the GPP allows us to generate G-code output formats specifically for the controller. And everything this is actually done, created, edited, and debugged within the Visual Studio Code. And we have developed so many of them. I'm just going to give you some of the machine brands that we have recently did. Of course, they are also for the Swiss type, also including the Stars, Citizen, Tordos, Tsugamis, all of them in front of yourself. These are the ones that we cooperated at most. And in the next slide, I couldn't put all the posts that we have here. This is one of the most updated based on this machining brands. But at the bottom, all of you are going to get this presentation, so you can always click at the bottom, so it will give you to the Excel sheet where we have all the posts available there, whoever is interested into it. And something about technical support. This is the most important element of CAM industry. Every CAM stands on the two legs. Software from one side and technical support from another side. If you don't have a good technical support, you cannot be good in CAM. Absolutely not. So SolidCAM is making sure that we always, whenever we develop a post-processor, we always go to the customer side to ensure that the defined post-processor works exactly on the machine. Now, for something like this, I mentioned that you need to have a technical team. SolidCAM always makes sure that we always train our team as well. So for example, in 2023, we had 2 post-processor training, one held in Belgrade, another in Bangkok, one for the Europe and another for the Asia. In total, it was 130 attenders for the only advanced Milton and Swiss type. So please, it's a huge team. So we are making sure that all our technical guys is up to date for the version to get most of it of our software. And as you can see here, this is the talent team, one of our first Swiss type projects that we have, again, to ensure that the defined post-processor works at the customer side. And this is the recent training in Belgrade. We had it in February. And the last point of my presentation is the setup sheet. In the past, you all know this was called tool sheet. We changed now the name to the setup sheet. It involves more. And this tool was ordinarily made by Stanislav Wawrik. I don't know, I see you, you're there. So, and everything was very good, but he always wanted to bring it to the higher level. So we involved also Milan Grigorievich, who is also the manager now for it. And together with Ruti, I called this fantastic trio who bring, tool sheet to the setup sheet level, what is today. It is completely amazing. And it was so important when I was going to the customer side, especially for the Swiss type, they always were demanding different format for the setup sheet. So we wanted to make sure that we can do that, right? And something about that, I want to encourage every customer now who is watching us also that they can go to the setupsheet.solidcam.com. They can make their setup sheet by themselves. It's so easy, it's so intuitive. For all milling applications, you can do it for the most and latest SolidCAM version, just online. Just download it, there's full instructions. And if you struggle somewhere, you can also Google, you can also go on YouTube and you'll find 3 videos about it, as simply as that. And last for the 2023, we also start supporting channel synchronization. So the channel synchronization will be able also to be completely exported from channel synchronization into a PDF or any other format. And thank you for this. This was my first presentation, and hope you like it.
Daniel, wait, there are two
Yeah.
questions.
Okay.
One is, can the setup sheet be exported for Swiss type? And the other question is there going to be a webinar for all the technical stuff that you talked about?
Okay, great question. Okay, first, yes, when we say the channel synchronization, even if it's milturn or Swiss type, yes, absolutely. We can generate it either for the milturn and Swiss type together. And the second, the technical, yes. So after this emo, after this exhibition and after the emo, we are going to create some technical webinar series, also connected to my next presentation. So please stay tuned. I'm going to jump into another presentation. Okay. My next presentation is about what's new in SolidCAM 2023 in general, and also about SP1. And you heard that I'm Vice President for Technical and Post-Processor Support. But lately, I'm honored to be also in R&D as well. And I got that opportunity to be also involved part of the modules in SolidCAM. So thank you SolidCAM for that. Now, what I'm going to tell you about. So first, it will be about the setup sheet, toolkit, and channel synchronization. Now, you probably have seen in my last presentation that we are now going to allow users to define fixtures through our toolkit. Now, let me tell you a short story about it. As I was doing a lot of milturn, Swiss type, going to the customer side, and I was thinking, how we can improve this. Let me just short you a little bit something about 2022. Fixtures in 2022, you could always do it in the way that associative fixture, where you have the 3D model in your CAD environment. In SolidCAM, you pick it up, that's your fixture. So this was like 3D model of fixture associativity. This was running great. We had two more options. One was the 3D parametric jaw, and it was 2D sketch jaw as well, right? So this was all supported in previous versions. But what always bothers me, like why every time I need to define chuck, my vices, and from part to part, like this was always for me a struggle. Every time you need to define it for every single CAM part. And we were thinking about, we have amazing toolkit. All these possibilities, libraries, how to manage the 3D models, machine preview, everything is there. We also say in 2021 that this is the platform for all future development. This is another step that we are doing it. We allowed, from now on, in 2023, fixtures to be defined there. You've probably seen a lot of presentations about it in What's New. Emil shared it already by the email. Of course, you've seen it. And with the toolkit, when we add this option, there was completely irreplaceable that we also need to improve a little bit our machine setup. So we changed this also a little bit. So you got all of these slides and stuff, but I have decided that for this event, I'm going to do a live demonstration for you. I'm going to use a standard milturn part that I'm using in most of my webinars for this demonstration. It is a standard milturn pod. I very like it. And I will just immediately jump into a setup. I'll open machine preview just to show you what is kinematic about. And we have here a classic NTX, 2 channels. There is no chucks, neither on main spindle, on the sub spindle, so there's nothing inside. Right, so what is changed here? Let me see if this works. It worked great. As you can see on the first side, it still looks more or less the same, but there are small things. So let me just introduce also for the people who know or don't know. Always this first page, we call it a fixture page, where you define your fixture, 3D model, and you are going to shift it relatively to your table station. Another page, which is this one over here, is a part mounting, where you're going to mount your part relatively to the fixture. Okay, so what has been changed? From now on, you still have the same options. I have no fixtures defined here at all, but I'm going to define them now. So you remember what I said. The first way, what we always supported, is associative fixtures. So let me show you how you can do it now and what is actually different. So you could still go with these 3 dots over here, but you can also click on this icon over here. So I'm going to open a toolkit. And on the first side, you can see that everything is more or less the same as the toolkit. But don't be fooled, because this is not 100% the same application as the toolkit itself. So the first thing, as you can see, on the far left, you don't see any tools that you can define here, but strictly only the fixture. So the first thing that we have added is this fixture icon over here. Right after it, we have a space where we define all possible components that you could do for the fixtures. So the very first is associative fixture that I just talked about now. Then we have these two elements or components consist of every fixture can be made by using only these 2 components. They're kind of 2D, as you can see, as a drawing. So those are main components. And also at the bottom over here, you can see that we, for SolidCAM users, prepare 3 templates for the vise, chuck, and collet chuck that you can just drag and drop and it all works. To make it easier so they can see how we actually build those things. Okay, so over here, I only see my tables. I see nothing more. And what I'm going to do, over here in my project, I have prepared a collet. Now, for all milling users, you can imagine that you have a huge libraries of components for your vise or stuff. So I just use this particular component, very simple, just to demonstrate you how you can define. I just drag and drop associative fixture on my main spindle. I will click on Import from CAD. And you're getting to the same interface as you had it before. So you click just on the 3D model. I can call it here, collet. And here, as standard, you have still the fixture mounting coordinate system and part mounting coordinate system. I'm going to define them. They will be here at the bottom. This will be the mounting point. And over here, I would like to define my part mounting point. So let's click on that. And what is now different? This is pretty much the same interface that you can see for the coordinate system management, but you see that very first time, a great job by Sydney and their development team, they make associative coordinate system. Now, in any earlier version, we never support really associative coordinate system in fixtures. And I'm going to show you what is the benefit of using that. So I'm going to just click on this. The coordinate system is created. I want it over here. So I'm just going to pick the Z level, click on this surface. It's clear that my coordinate system is created. I click OK. I'm going to repeat the same process for my part mounting coordinate system. But this time, I'm going to click on this. It is there. I'm going just to ensure that it's always on this face over here. I'm going to click OK. You can click also on these icons to ensure that your coordinate system has been created. Of course, this is not a must. If you don't create it, then the coordinate system of Mac will be used instead. But I want to use it in this demonstration to show you the power of associativity. I'm going to click OK, and the behind the scenes, SolidCAM is actually generating the STL out of it. Here it is. So on the right side, you can see for the first time my mounting position, but also something that we never had before. We visually display for you where is my part mounting, so for the offset, you can offset it from that point. And over here, you can see the structure. I have the collet with my index here that is associative, and I have the part mounting. Now for the first time visible, and a new component in a toolkit. I'm going to click on it, and because it's associative, you can see that I read all the data correctly, and it is not possible to change. You can change it only inside of your CAD model. All right, so that's great. I'm going to accept that. I like this fixture, and it's there. My part is there, my fixture is there, done. Now, if I click on this part mounting over here, I can now offset my part. Let me just move it. But what you can see now, here, you can see this part mounting now for the first time. So every shift and rotation is based on this coordinate system that you can see. Okay, great. So what's next? Let me put this on 80 here. Everything is okay. I'm going to save and exit here. Now, I don't need this 3D model anymore. I'm going to hide it, and I'm going to show you one toolpad that I have over here. This is just a simple finishing turning toolpad that goes along and fairly to the middle of the part. You can see that clearly. I'm going to open my setup again. I will go to my part mounting. I'll open a preview. I will use my also focus on the target. I can also use these tools. And I will, for this demonstration, I will move it a little bit further, just for the purpose. It is clear that if I put my fixture and part in this setup position, my turning toolpad is going to hit my chuck, my collet button. I'm going to save to an exit. Nothing has to be recalculated. It is done on the demand. I will do a right click and calculate. New toolpad is there. Let me show you a couple of more things. So we always had these features, but not too many know about them. So I have here my SolidWorks environment, but you could always click on this small icon over here. You can click, and now you can, even in SolidWorks environment, see where you actually are at any moment. What you can also do, you can generate a fixture envelope. You have the icon over here, and you can click. And now SolidCAM is going to generate envelope of that. And now I don't need this anymore. I can continue working, and I know where my fixture is. So what is happening if I just take this and I just move it? I just click on this. I don't need to go to the preview. Fairly new position. OK, let me generate it again. The previous one will be removed. The new one will be generated. All right, so this was more or less all the things that you can do even in the milling application. There's no boundaries on that. But I want to show you something more. So I will just click this on none. I don't want to use any. And I'm going to open the toolkit. I'll open my machine preview. I have no chuck. I have nothing there. And let's see how easy today is to define a chuck. Many Milton users, let's say not really many, but I would say like 25 or 30% of them, fairly oftenly for a specific Milton application, they are changing their chuck to the bigger, smaller one, or maybe sometimes to the collet. You never know. For those kind of customers, you want to have a fast solution that he can pull out from the library and use it very fast. So how to use the chuck? Just take this template over here, drag and drop, your chuck is done. Now, if I look at this, so I have the chuck body, I have my part mounting, I have a jaw. So we have, let me just close this one. I can now visually again see the part mounting. And this was always like a challenge. Some customers like to measure the offset from the face of the chuck. Some customers would like from the face of the jaw. No problem, in any moment I can go to the part mounting, I can put here the correct values, and here it is. I can now give the user all possibilities how this will be measured. Let me bring it back to original state. And let me just click on the jaw page. This is something that you are probably familiar and seen it before. But it is organized better, of course. But from another side, we also have all those I'll call boxes with values, but they are dynamic. What it means, so for every value that you change, everything is very dynamic. And another improvement, small improvement, is that every of those steps now can be defined. In comparing to the previous version, where this was not possible, we define it differently. We can also define the number of steps. Now, for the first time, we can go with 1, we can go with 2 steps, we can go with 3. Also, the number of jobs, I can define 2, I can define 3, 4, 5, and so on. Look how fast this is. Also, I have my clamping reference position, so I can, in any moment, change my reference point. So I can just say this. I can also increase my clamping. I can flip my jaws. It's so nice, so intuitive. What do you say? Okay, let me do something. I will flip this around, put this to 0. And my part dimension is, let me check, it's 40. So my stock is here seems also 40. So I'm going to define my clamping dimension like 50. So let's imagine that I place it a little bit opened. And this is, of course, you never know what clamping dimensions you're going to have. So you can just leave it more open. And I'm going to accept it. Okay? I'm going to open my preview. My part is over here. I'm going to move it to the part page. Let's say I want it here. Okay, what we have here, more. It's obvious that my chuck is moving everything. I can control the clamping positions and stuff. I have here clamping axis that I can control. This 50 M that I put, you can see it also here. But we have something new. We have also something we call auto clamp option. So I'm going to position it here, and I'm going to click on this auto close on stock. Next option, what I can do, it's auto close on target. Very convenient when you have a back spindle as well. So of course, in this case, my jaws are going to be closed on already machined geometry. So in this case, I will just auto close on target. Here it is. So please, do me sometime. So what is the advantage of all of these? So I can now predefine all of this, and I can store it in my library, reuse it in my project. So let me go next thing. I'm going to set this to none. And let me show you the library itself. So you can click on the library. And here I have predefined all standard chucks, vices, and collets that I could find. And those are kind of components. So what is different? It's different that here you have those fixture folder, and now you can, in the same way how you define your cutters, shanks, adapters, and holders, now you also have a fixture holder. Okay, I also have predefined my assemblies. So I have here a metric, and I can, for any, I predefine my vices, but here I have some chuck that I can say, let me put this one on the main spindle. Here it is. It's completely 3D model defined. I have just defined them. I just download the 3D model from the manufacturer. I predefined it inside my toolkit. I just drag and drop to my table station. Close on stock. Done. The same wise, I can just place it on the sub spindle. I can define all those things. So all things are more or less the same. But let me show you another things. Another small technical stuff. Not only that you can do it like auto close, but you can close it to any clamping dimension. So for instance, I can just click on this dimension over here, and I can click on this diameter. You can see dynamically how he changed it. I can click on this, I can click on this diameter, and it's changed as well. Small details, right? And before I go to milling application, I want to also show you a couple of things there. Small features more inside the toolkit. So we have here at the bottom, favorite tools, a new option here available, which allows you to seek for the last 10 tools, cutters, shanks, and holders that you use it. Very convenient, especially if you're oftenly jumping from one library to another library. You can very easily, locate those components, and you can easily drop it in your project there. Also, there's an option that you can do a right click, and you can pin it, as I did it over here, and there is a small index here that this particular component is pinned, so to ensure that every time when you go to the toolkit, you're going to see this particular tool. Also small feature there, and improvements. And now, something completely new that we never had before. And it's connected more or less to linear and revolvers that I like to use. I was always struggling, and I know that every one of you was struggling with this. And I'm going to take one example here. I'm going to take this tool, tool assembly number 2. I'm going to select this tool component. I'm going to close this and just use it like so. Okay. I'm going by the purpose. Here, this is selected over here. And I'm going to select this component only. And let's say that I'm going to shift it in some unknown direction. Many times it happens to you as well. So let's say something like this. So I remember our very first versions of the milturn. For me, the biggest challenge was I want to know how to snap to those surfaces and to place my tool into a holder, into a shank, right? So how to do that? There is a new tool, and you just click on specific component. If I click on this shank over here, it will move together also my insert. And you have an option here. It is called Calculate Orientation and Position. I'm going to make it a little bit bigger so you can see it. And when you click it, it will pop up something like this. It's a new tool completely that allows you complete manipulation of your STLs inside the toolkit. But not only toolkit. The same tool you will find inside the setup for your fixture movements and also part relative movements. So, how it works? I'm going to click on my surface, which is face number 1. Face number 2, I'm going to match. If you want to undo it, I can just undo it. I don't like it. I want just to move it along the z-axis. As you can see, this is along the z-axis. So I can just say here, I want to move along the z-axis, just z-axis. Then I can delete this. Let me click this and this one. So I have 2 surfaces. I want to move it along the x. Okay, let's go along the x. There we go. But I want to apply the 10 of millimeters in the distance. So here's the 10, or maybe you want 20. Or maybe you want to flip it. Complete manipulation is now allowed. This is not only in Toolkit, also inside machine setup. Another feature that is not finished, but we are working on it. You can see it. Just to bear in you that this, we are working on the feature to allow also selecting on the specific surfaces and circles. So stay tuned with that. It's coming in the next releases. I'm not going to save it, and let me go to a milling application. As you see, I'm using fairly simple parts, and in this case would be also the same. And what I want to show here, I didn't show in, of course, I didn't want to really attach my vise on my spindle. That will be pretty funny. And for this, I just have fairly simple part. I have one machine. I have also no fixtures defined. My part is inside the table. Everything is there. So let me see how to define a vise. I will open my tool viewer, and I have here the station. What is enough is just take the vise, place it on station. This is, guys, what you're going to get as default. Whenever you drop this particular vise, it will be there. This is a default one. But of course, you can prepare, and this is, I think, ultimate goal, to prepare already a database. So I have here one that uses something like this, pretty much soft jobs. I have my clamping axis. So I can move my clamping axis, as you can see here. Of course, I will just leave this value, as you can see. I'm just going to accept it. It is there. Because my machine, it's like there are components that I'll just hide it for a moment. I'm going to move my part along the y-axis, just like so. And again, you have close. That's it. But that's not all. In any moment, guys, what is the power of it? Very often, you want to change some of the jobs, right? So here is where your library gets into a place. So you can go to the chuck. I have here using, sorry, not chuck, but vices. I'm using this particular one where I have some of my list of the fixed and movable jobs. So I'm going to replace the fixed one with, for instance, this one. So I want this one, or maybe this one. Yes. So I'm going to take it. Just replace here. I didn't hold the alt click, so like so. And also for the movable, I'm going just to take it also and hold the alt key. There you go. What you can do also, you can click on any of these jobs and flip also work. When you flip those jobs, it is obvious you're going to get more distance space. If you have a little bit larger stock, you can also clamp it like this. All right. Next thing, let me just accept this. I didn't have to. I'm going to click on None. And for the first time, I want to show you something that we have completely new. I prepared this also as a component on the component level. And I here have 5-axis 3-sided. It can be also a pyramid system. Fixtures, you all know about this, you heard about it. Mostly our customers were doing this thing still, but like load it inside your CAD environment. And then just for every part you need to, again, click. Today you don't have to do that. You just define it once, you're assembling, that's it. So I don't want to do it in the tool viewer, but I think it's more interesting to show it in machine preview. I'm going to take my table, drag and drop. It's a Lego, guys. It's just like play with this. You still can rotate your model as you do it also in all Toolkit options. This is also available. You have here, I'm going to place, this is my number 1. Next is my vise. I'm going to place my Ys. I'm going to place my Joe. Here it is. I'm going to add a part mounting. My part mounting, it's in my previous component, so I'm just going to measure. It's really up to you where you're going to place it, and for me, I'm going to place it over here, which is 62 something, so on 62.5 I'm going to place. Here it is. This will be my part mounting. I'll click OK. My part is, oh, I forgot to open it. So I have here my clamping dimension, so I'm going to open it to open position. What I can do now, I can just copy this. Look how easy it is, guys. Fixture, paste, paste. Done. But this time, something is different. I have my part mounting 1. I do also have my part mounting 2. I also have my part mounting 3. Now I have a possibility for the first time to define 3 mounting positions. I'm going to click OK. I have my part. It is there. I'm going to click over here. What is now different? I have now 3 positions where I can place this part. So I can place it here, I can place it there, I can place it there. So it's really up to me what I want to do. I'm going to just move it here. I'll just ensure that, let me just place 10. I'm just going to close. You can see he closed properly. Or I can go a little bit further, just close it. Close it. I can also go, stay tuned. So I can go to the Joe. I can just flip it. I can accept it. It works also from another side. I click, close. So a lot of new possibilities, but everything at the end to the goal that we give users now an option to define all these libraries, predefine them, to not waste the time in preparing it. So you can prepare everything in ahead. So anytime when he opens a new project, all the fixtures can be defined for him automatically. 3 mounting points. What allows us? When you have 3 mounting points, you are allowed to create a new MCO, and you can take the CNC operator, and now you can move your stock from one wise to another wise. The same philosophy like in the milturn, when we have a main spindle, sub spindle, at the end we add a new workpiece, and we are going to see 2 parts machined together. The goal is that you can also create it also over here. You can machine all 3 parts at the same time with one, inside one, of course the channel synchronization is handling everything, but now this is possible. Let me go to my presentation. So the new fixtures will allow us to completely define modular concept of the fixtures. Also replaceable tables, very convenient when you have a milling table or turning table in all previous versions. What we did, we create separate machines when he's doing milling capabilities, when he's doing turning, right? Complete control of the tombstones, of course. Now, with all this, and Michael is going to talk tomorrow in the roadmap for SolidCAM, something that we are preparing in very close future. All these three part mounting points that you've seen, we want to do something further. And we are building a platform for it, so I will leave Michael also a few words for tomorrow, so stay tuned. And one of the reasons that pulls that is that our channel synchronization, we changed the name. We changed the name to the Operation Sequence Manager because even for some milling machines, these you are not really synchronizing any channels because milling machines are completely single channel, right? So we make sure that also for the future development, we change this to more logical name, which we call Operation Sequence Manager. Another feature that is very connected to axis patterns, which are mostly available in the Swiss type, is that axis pattern for the first and last was always the same. But however, now, especially this was for the star machines that it's important that also the last can be changed to any you want. With my previous slide, a new license update for all users. Operation Sequence Manager for a single channel machine is now available for free. So what you need to do in VMID, you need to define that your specific machine is single channel and channel synchronization is going to be available. And with this, I'm going to thank you for your attention. I hope you like it. And
Thank you. Daniel, there was one question. I don't know, maybe it was in the middle of your presentation. Somebody asked, is this possible for CNC rotary tables? I don't know what...
CNC rotary tables.
Something you were talking about, and they said, is it possible for CNC rotary tables?
Okay, good. Yeah.
Okay, after he answers, we go to a break for exactly 15 minutes. Please come back in 15 minutes.
So the question I hope it was about that. Imagine that you have a 3-axis Haas machine. I think it's good representative. And very oftenly we come with questions like, hey, sometimes I would like to put my 4th axis, maybe along the x-axis, sometimes maybe along the y-axis. Sometimes I move it on my table, so I would like to define that and not every time to change my post-processor. So this is just a small platform what we built in our, and also I don't want to ruin Michael's presentation for tomorrow, but we are working on this solution, of course, yes. Currently in 2023, no, but stay tuned.
want to design a part, come up with the G code, get to my machine, and make it as fast as I can. Because time is money. And no matter where you can save money, I'm going to take advantage of it. And in addition, I've been very impressed with the finish that it does by doing full-length cuts, and what it will do to save me money in the cutters that I have to purchase also.
Hello. Good evening, everyone. Thank you. For people who don't know me, my name is Amod Onkar. I'm the country head for India and also the product manager for 3-axis and 5-axis milling solutions. Today is 5th September. Can anybody tell me the relevance of the day today? I don't know about the world. Today is Teachers' Day. So we all have teachers in our lives, right from the time when we are born. We go to school, we have teachers. We go to the college, we have teachers. Even in this room, we have a teacher. Emil, happy Teachers' Day. We have learned a lot from you. Okay, so first of all, what is a unified engine? So there's a story behind it, and I wanted to really tell you a very beautiful story about this, but I did not have any words, so I wrote to Perplexity, which is the AI software, to give me a nice story for the unified engine. It gave me a story that was more relevant of Shakespeare, and I forgot about the story completely, and I think it's better to tell you the truth rather than to tell you some nice story on what and why and what is unified engine. Basically, unified engine is a combination of two components. The turbo toolpath that's already there inside SolidCAM, and there's another engine which is called as a classic engine in ModuleWorks. And the combination of both of these engines together gives us the unified engine. Why was it needed? Well, one day I got a call from ModuleWorks saying that they wanted to discuss the future of turbo. And in one of the meetings, they informed me that they have two teams, one looking after the turbo engine and one looking after the classic engine. And they said that it's becoming very difficult for them to manage both these teams together, and they wanted to focus on one single unified engine, and that's how this unified engine was born. We have been testing this engine for the last 1.5 years, putting it through different what-if scenarios, putting a lot of paths through it, and we have come to a conclusion that it's now cooked and it's ready to release. So we're going to be releasing this pretty soon. So basically, unified is a new generation engine because it combines two big engines of ModuleWorks together to give you a very powerful toolpath generator in 3-axis. It gives you, first of all, the power that was there already in Turbo 3D HSM, and it gives you complete control. If anybody has been working with the Turbo 3D HSR, unified is an extension of Turbo 3D HSR, so it uses the same principle. It offers a very optimized algorithm, improved accuracy. Now, this is one of the things that caught our attention in the last 1.5 years that we have been testing this engine, is the accuracy of this engine is much, much better than the current two engines put together that we have inside SolidCAM. So it's way accurate, gives you a much better surface quality because of the accuracy. Collision-free toolpaths. Now, this is another very crucial thing that was missing in both our legacy HSM as well as turbo HSM, especially when using holders. When we're using holders, it was extremely difficult to find a very good toolpath that would trim the toolpath to the holder and then give you this optimized toolpath for machining. Multi-surface offsets, they give you the possibility to define different offsets on different groups of surface inside finishing in the unified engine. You can also define fixtures, and the fixtures are not taken into account just for the purpose of trimming, but the fixtures are taken into account when it actually starts calculating. So you'll see a big difference. I'm going to show you the difference between our existing Turbo 3D HSM when defined with a fixture and the unified engine when you define it with a fixture. Now, this was something that was a learning for us. We thought that this was already there inside SolidCAM. But both our legacy HSM as well as our Turbo 3D HSM use what we call as 2D trimmer. We take the boundary of the surface, project it to a plane, and then look from the plane and then trim the toolpath. Now, this works very well when you have flat surfaces or near flat surfaces. But the moment the surface becomes more or less steep, the 2D trimmer starts giving problems. So you'll see a lot of retracts coming out because of the 2D trimmer. Whereas in Unified, we are doing true 3D trimming. We are not projecting anything. We are just taking the 3D boundary as it is, and then using the 3D boundaries, we are then trimming the toolpath. So it's much more accurate. Boundary definitions are much better inside the Unified engine. You can just select either one surface or group of surface, and it generates the boundaries, whether it's a contact point boundary or a tooltip boundary, so it generates it automatically. Most important thing is the arc generation inside the Unified engine. I remember a few of our resellers demanding this inside the legacy HSM as well as in the Turbo HSM on the arcs. And we could only do XY arcs in Turbo 3D HSM, but with the Unified, we are able to now generate arcs in any plane. That will need some adjustments in the GPP, but we can now output arcs in any plane. Whether it's XY, YZ, or ZX plane, we can output arcs in anything. Whether you're doing a linear machining, rest machining, constant step over, whatever is the toolpath, you can now generate arcs in those planes. Another very important thing that we have inside Turbo, the Unified engine, is the feed rate, which keeps automatically adjusting based on the geometry that is being machined. So if you're going in a very tight corner, the feed rate automatically drops to go around that corner much more easily without damaging the tool. So this is a feature inside the Unified engine. So what are the strategies that are available? Unified, like I said, is a subset of the Turbo 3D HSR. Okay? So obviously, I would consider the turbo or the high-speed turbo roughing as a part of Unified engine because the whole thing is one engine. So we have the roughing, rest roughing, hatch roughing, all of them coming in the Unified engine now. And of course, in finishing, we have got a host of machining strategies, and I consider geodesic machining to be a part of this. So the geodesic machining, when added to the Unified engine, completes the offering that can actually, I can confidently say, can replace our legacy HSM engine. You can totally stop using it, and you can move completely to the Unified engine along with the geodesic engine. About improved accuracy, we have seen a substantial difference in the way the toolpath is generated using the Unified engine. It respects the tolerances much better than even probably the legacy HSM and Turbo HSM. So we get much better results now with the Unified engine. We have already seen this by machining few parts, and we could see the difference in the results. Now, another very important thing is the dynamic holder checking. You can look at the left-hand side, that particular part, you can look at the retracts, you can see the retracts. That is because in Turbo HSM, or even in our regular HSM, when you define a holder, the holder is the last element that is being checked in the toolpath. Okay? Ideally, that should be the first element to be checked in the toolpath, but that's not happening because most of these toolpath engines are designed to take the holder and check it at the end and then just do the linking. Whereas with the Unified, the holder is taken into account while in the calculation stage itself. And using the 3D trimmer, it separates out regions and then links them separately at the end. Therefore, you can see that the toolpath is much clean. It's separated in the region-wise much cleaner than our regular Turbo 3D HSM or the legacy HSM engines put together. Multi-surface offsets allows you to define different offsets for different groups. You can define infinite number of groups, and you can define different stock offsets for that, and it will generate the toolpath in such a way that it will keep those, or it will respect that offset in those regions. Fixture definition, also exactly like how it used to work with the holder. The fixture definition was always applied towards the end. It used to just trim the toolpath and then just link it. But that's not how it works in Unified. In Unified, it is considered to be a part of the geometry. Okay? And considering it to be a part of the geometry, it uses this geometry to develop the toolpath or generate the toolpath by taking the fixture into account right in the very first stage, rather than taking it into the end. Therefore, you see the kind of retracts you get when you use the turbo HSM with fixture and with the Unified engine is completely different. The Unified is much, much clean engine when it comes to the fixture definition. 3D boundaries, like I said, this was a revelation to us because I did not know that we do 2D boundaries only. Our HSM and turbo HSM both take the boundaries, project it to the XY plane, and then use that XY plane as a trimmer to trim the toolpath according to the boundary that was selected. Whereas with Unified, there is no projection. It takes the boundary, the 3D boundary as it is, and trims the toolpath according to the 3D boundary. That's why you'll see that the Unified toolpaths are much more cleaner and represent the surface much better than the turbo toolpaths. Arc fit. Now, something stuck to me, I don't know if you can see it, but actually, turbo 3D HSM is generating more arcs than the Unified engine, okay? Almost 2 times, it generates more arcs. So if, let's say, turbo is generating 9,000 arcs, Unified will generate 4,500 arcs. And this was one of the features that was told to us that it's going to be pretty good at generating arcs. But when I saw that it was generating less number of arcs, we started investigating. I checked with my QA people on why this was happening. And then we realized that Unified generates whole arcs and not pieces of arcs, okay? Whereas turbo generates pieces of arc. Now just imagine that you're machining a hole, just a cylindrical hole. Turbo would generate 3 or 4 arcs on one level, whereas Unified will generate just 1 arc on that level. And that is the reason why it generates less number of arcs when you compare it with the turbo 3D HSM toolpath. Also the number of blocks. Turbo 3D HSM, when compared with the Unified, Unified generates almost 30% lower number of blocks. G-code file is at least 30% lower than the Turbo 3D HSM, or for that matter, HSM G-code. This not only helps you to machine faster, but it gives you a much better surface quality when you actually take this part and go to the machine. We did these trials, and we saw that the arcs were coming very well, both in the XY plane, it came very well in XZ plane, and it also came pretty well in the YZ plane. So it could generate arcs in any plane. So the only catch here is that you need to go back to your GPP. You need to ensure that your GPP is configured to output arcs in any plane given. Another thing was the feed rate control. So Unified now allows you to define ranges of feed rate that it will apply when going in a corner or in a very tight geometry. So if you have defined a feed rate of 2,000, and if you say my minimum feed rate that I would like to apply is 50%, it will ensure that when it goes into a real tight geometry, the feed rate automatically starts dropping till the time it comes to the 50% and then again accelerates in the other region. So this gives you A, much better tool life, B, much better surface quality in the corners. There are other features. Of course, I did not put it. It would have unnecessarily increased the size of my presentation. But there are several other features that are there inside Unified. For the interest of people who would like to check this engine, it's already available in the SP1 release. It's available under the beta options. So you can switch on the beta options, you can switch on the Unified engine, and the Unified engine will be available for you to test on even real-world parts. It's fully ready. We are just doing the final checks. SP2 is when we are actually going to launch the actual release of the Unified engine. Couple of things to note. There are conditions. If your old part, if you're trying to open it in 2023 SP2, when the Unified engine will be available, and if your old part does not have any Turbo 3D HSM toolpaths, Turbo 3D HSM will not be seen in the tree. Okay, you'll only see the Unified toolpaths. You won't see Turbo 3D HSM. But if your old part has a Turbo 3D HSM toolpath and you open it in 2023 SP2, you will still see the Turbo 3D HSM toolpaths in the tree. You will also see the Unified engine. So you will have you or your customer will have the option of opening either one of these engines and working with it. But if it's a new part or a part that doesn't have any Turbo 3D HSM old toolpaths, it will not be available for the users in 2023 SP2. It'll be completely blacked out, and you will only see the Unified engine. So these are the other features that are there currently inside the Unified engine, like boundary contract point definition. You can now define boundaries for stock boundaries. You can define boundary for part. Okay, there are two different methods. Machine only vertical walls. So if your part has only vertical walls, you don't have to select anything. You don't have to put any kind of slope angle. You just say machine vertical walls, and it will only machine all 90-degree walls without any definitions. Another very important thing, people who are coming from the mold and die background, the edge rolling is one of the most critical aspects. Okay, if your current toolpath, our HSM as well as Turbo 3D HSM, don't have any mechanism to prevent edge rolling, so that when you see the toolpath, when it starts, it'll actually start from the sharp corner and then roll down onto the surface. This blunts the sharp corner on the top. Okay? To prevent it, the solution is they'll just extend the surface and start the toolpath way above to prevent the edge from being damaged. But that's going to be taken care by the Unified engine just by selecting a small checkbox that says prevent edge rolling. Then we have adaptive step down, cross machining like what we have in the HSM, rest finishing by stock. So you can have rest finishing by previous tool, or you can do rest finishing by previous stock. Both are available. Not roughing, I'm talking about the finishing part. We have independent cutting method. You'll have climb for, let's say, constant Z, and mixed for linear. And the most important thing is we also can now overlap both the tool paths. Both constant Z and linear can now be overlapped either by a value or by an angle. So these are some of the extra features that are already there in the Unified engine. Once you open up the beta, please get in touch with us. You might require a little bit of orientation training, probably a couple of hours, and you'll be good to go. So if I summarize the Unified engine, it has collision-free toolpaths because it takes into account the holder geometry, and of course the part geometry is already taken into account. Multi-surface offsets, fixture definition is much, much better now. And of course, we have got 3D boundary definitions that trim the toolpath precisely to the 3D boundary. And efficiency of the toolpath is much better than the Turbo 3D HSM as well as HSM because of the arc fit function that we have introduced inside that can totally reduce the number of blocks that are there in the G code, resulting in faster cutting. We have already seen it on the machine. We can sense it that it's much faster than the previous engines. So basically, Unified engine currently is available. It's under the beta option. Anybody wanting to work with it can switch on the beta option, and it'll be available to them to check and test the conditions. I've told you, if it's an old part with Turbo 3D HSM, only then you will see Turbo 3D HSM. If not, Turbo 3D HSM is gone forever. You'll not see Turbo 3D HSM at all. You'll only see the unified engine. This is only to make sure that people start using the unified engine. And if you ask me today, is it ready to replace HSM? I would say unified engine plus geodesic can replace HSM totally. You won't need HSM at all. It's completely ready to be replaced. Questions? No questions? I have a question. Myself. 1 minute, please. What is the future? Beyond the unified engine, what is the future? Okay, we are working on a very, very complex topic of toolpath editor. Probably early next year, we should have our own toolpath editor capable of doing toolpath editing on all 3-axis toolpaths, whether it is HSM, Turbo HSM, whether it is HSS, geodesic, anything. We should be able to do exactly the same kind of toolpath editing functions that you see with our competitors, probably better, because we are going to erase their mistakes, not take the same path of what they have done, but we are going to chart our own course. We already have some kind of a conceptual product ready, but there's no GUI at the moment, so we are working on the GUI, and probably by end of this year, we'll have something to play around with, and I would be inviting you all to also start working with the toolpath editing functions and giving us feedback on the same. Thank you.
Okay, so hello SolidCAM family. Hello SolidCAM family. Okay, I hope after such an interesting lecture, you are not sleepy. And actually, it was truly exciting to be here in such an amazing annual summit of SolidCAM, now in Istanbul. I think the best and the biggest summit ever. Okay, I'm going to talk, try to in 30 minutes to show you the best high-end solution of SolidCAM. And all of this it will be based on part of existing customer from Israel. I hope you will enjoy it. Okay, so we start with SolidCAM solution to advanced Milton multitasking machine. So you know, most of the many factories worldwide equipped with those machines more and more. And the reason are, they want to machine faster, they want to make it more accurate, and they want to complete the setup in one time, to finish the part in one setup, excuse me. And include all the milling and turning operation in one part. This is very important. This is the reason this market is growing from year to year. As you can see in Israel, for example, we have 570 seats of full milturn. When I mean full milturn, it's a milturn with X, Y, Z, C, B, with back spindle, with channel synchronization, with all the functionality needed. We have today, SolidCAM, we have a complete solution, a very strong solution for milturn. And we have now a great opportunities time for all of you, and we must leverage it. This is the time. As you can see, we support the most important brands in the market, like Okuma Multus, like Mazak Integrex, DMG NTX, Nakamura, Bumatec, Villeman, and so more. all the important brand in the market. So as I tell you, I want to show you in each subject some parts from our existing customer in Israel. And this first part is actually a simple part, but for milturn, and it will show the strong functionality of SolidCAM with the wise technology of the user. You can see the part is very small, 58 millimeter on the 30 millimeter width. Oh, they changed me a little bit the slide, but okay. And we have a few challenges in this part. First, we need to avoid vibration. Accuracy is very important in this part. The size is 58 on 20 millimeter. And mass production, 1,200 pieces. It means every second, every minute for the factory is pure money. So it's very important that we have a strong functionality and wise technology. Let's see how we did it live in SolidCAM. Not me, this user. Let's start. Okay, we are now inside SolidCAM. I just recorded myself. So we can see here a part, 58 millimeter. Look at the right side of the bar here. It's just 4 millimeter diameter here, along 31 millimeter length of the bar. So it means we need to know how to machine it. The machine in this case is DMG Mori, as we have in Schramberg in our center. This machine with our fantastic machine simulation, machine preview, we can see that it's machined with a B-axis, with lower turret, with back spindle, main spindle, and we switch directly to our machine simulation after the user complete all the operation. So first of all, our MCO, fantastic MCO, which lets the user, as you can see, with spatial device, to pull out the part to the right size. And we start with the first operation, with the lower turret turning operation. We start with a face turning, and after it, external turning. But notice to the fact that this user is work smartly. It just cut a short portion of the part, not all the part, not all the lengths, because the process will be settable. So we finish with the turning. We change the tool. By the MCO, we move the device to safety distance. And now with the B-axis, we complete, in this short portion, we complete all the milling also, all the turning and the milling operation in this short portion. It's very important to keep also stability and also the accuracy of the part. So we can see a profile, drill, chamfering operation. Immediately we switch to other simulation of fantastic that I like very much in SolidCAM. This is host simulation with host CAD. Beautiful. You can see we continue the rough turning, and after it, the finished turning, and we finish with this operation. Now we jump immediately to iMachining. But iMachining is for milling? No. iMachining is for milling, of course, but it's also for milturn. And why? Because we, first of all, reduce the time. It's very important. We have a wizard that the user can get all the cutting conditions automatically. The process is settable. And we can see now a milling operation in milturn with iMachining with the Cartesian mode from the side. And this user, of course, continue in all the rough cycle, he continue to work with iMachining. So now we can see, with the B-axis, with the top view, we continue to cut with iMachining. You can see the spiral motion. We're going to finish one side. We use very easily the index position in SolidCAM. We rotate it 180 degrees and continue with iMachining, continue to machine the other side. And you understand it, but everyone needs to understand. Every operation here, it's take to the user 10 seconds, 15 seconds, 30 seconds. Very easy to use, friendly. We change the tool, and we use rest iMachining. Finish with iMachining. And we continue now all other 2.5D operation. But look, we are working with different position. And very easily, it's a simple operation, but from multiple position. Yeah, we can see a drilling, we can see a profile, chamfering. Now we can see a profile with clear offset. Very easy to define, and the results is fantastic. Okay, the last challenge in this part is to detach the part, to disconnect the part, because we want to finish it in one setup. Before, we have HSS operation. HSS, for me, is in the core of the operation of SolidCAM. This is very strong operation that the user used HSS in every part. Look, we make now, very easily, we machine the fillets from one position, from the bottom with the lower turret. HSS, I will explain about it more later. Okay, now we're going to cut the part. So first, we use a groove turning operation. But now, how we will hold the part? The part will fall down. No, we don't want it. We use the MCO. Very easily, the MCO, we call the back spindle. The back spindle will come, will hold the part from the back, but now we have a very suitable holding. You see from the main spindle, hold, and from the back spindle, and now, with one operation, with profile, we kill two things together. One, we disconnect the part, and second, we will finish the right dimension of the part. Simple, but strong. Let's continue. So which tool we used in SolidCAM for machining this part? We use the fantastic Toolkit. I will talk about it later. We use machine control operation in every step. I'm machining for Milton. Machine preview. Machine preview is a fantastic feature for us because it's go with the user step by step, and it shows the user the schematic position between the tool and the part every time, and this is very, very important. I don't think another competitor have such a powerful things. We have full simulation. We have the Solid Verify, new simulator, host CAD with Solid, machine simulation. We have variety of simulation. Just choose. And in the core of our operation is the strong 2.5D profile, pocket, and you will see more in other parts, and of course HSS every time. Okay, let's continue. This is my favorite in the past few years. Swiss type, our solution to Swiss type. We are, Daniel mentioned it also, we are the best solution for Swiss type, no doubt about it. We have all the functionality needed. And we have also a very strong team, which is the second leg, in many sites of SolidCAM, many countries, like Germany, like England, like Israel. And it's very important that all the other will adapt and will think about how to build a strong team, because it's very important to sell the Swiss type. We have the functionality, but you need also a strong team to support it. So as you can see, we have 475 seats worldwide of full Swiss type. We support and we give answer to the most important brands in the market: Citizen, L20, L12, L32, all the types, Star, ST20, and more. I will not mention everything. And also Tornus Gamma. We have DMG Sprint also in Israel. Tsugami, it's very complicated, but we have solution to it. Nextern and Anawa. Okay. This part, another example from another customer, Swiss type customer in Israel. This is 20 millimeter on 5 millimeter. I forgot to bring it from Israel because, anyway, you cannot see it. You can see it just by microscope. It's something for medical area, this part. Okay. So what the challenges in this part? The challenges is accuracy. It's very small, so the size is very important here, how to do it. And of course, 3,000 pieces here. When we talk about 3,000 pieces, automatically we talk about Swiss type. Let's see how the customer deal with this part. So now we're on SolidWorks. You can see 4.75, less than 5 millimeter, a lot of slots, it's not so complicated operation needed here, but it's many operations from all the size. You see the special slot, the shape slot in the middle, drill of 0.85, yeah? Very, very small. So let's start. Let's start to program. We have a fantastic tool. We have the toolkit, and inside the toolkit, we have machine preview. Together, the programmer today, before he starts programming, he can see and mount all the tools and holders in the right station. Actually, he is doing exactly what the operator will do at the machine. But this is a huge advantage because he can see, before programming, he can see everything, where every tool is located, and this is very, very important and fantastic feature of SolidCAM. For Swiss type is useful, very useful. We continue to machine setup. In the machine setup, again, by the machine preview, we can, the programmer can define the material and can define any devices that will hold the part. As you can see, in the main spindle, how we prominent the stock, and in the back spindle, in the other side, where the special device that will come from the back and will clamp the part and will move it. Channel synchronization. Daniel talked about it. I'm sure tomorrow will be more about it. This tool is essential. It's necessary for Swiss type. You want to optimize the program. In Swiss type, you all the time need to optimize. If you want to save 2 seconds, you need to optimize. So you need this tool. And we have a fantastic tool. Channel synchronization is fantastic, very clear, very friendly user interface. You will see here that we synchronize 2 HSS operations. And now let's start. So in Swiss type, most of the time, we use the machine simulation because we want to see exactly what is happening in the machine. You know, in Swiss type, the narrow area in the machine, it's so narrow that you must have such a simulation. And in machine simulation, in Swiss type, if you define all the tools in the right way, so you will see exactly what is going to happen in the machine. Look now, two tools, 2 channels working together. We continue fast, yes? We see there is many operations here. Here, from one side, make the pocket, from the other side, make the profile. Thank you. We continue. Now we need to disconnect the part. In Swiss type, it's meant to cut off the part. So you see from the back side. And now HSS working together, 2 channels working together. This is efficiency. And this efficiency provided us by the channel synchronization inside SolidCAM. Okay, last thing in Swiss type, we need to cut off the part. In this case, we want to cut it and to transfer it to the back spindle in order to finish few operations at the back side. As you can see here, few operations like profile HSS from the back. Okay, so we have a fantastic solution. And as I said before, to succeed, we need 2 legs. One is functionality that we have. We have full solution to do it today to Swiss type. The second leg is need to be a perfect technical team. So in this way, we can leverage our goal. Okay. So which tool we use here? Again, MCO all the time. MCO also control and handle all the special patterns that are so important in Swiss type. Pattern is cycles. It's spatial cycle that's so needed in Citizen, in Star, and so on. Toolkit, you saw the toolkit, so important. We can see everything. iMachining was not in this part, but iMachining is also, like milturn, is important in Swiss type. Machine preview, the tool that goes with the user in every step. Full simulation, but mainly machine simulation in Swiss type, and channel synchronization, which is so essential. Okay, next high-end solution of SolidCAM. 5-axis milling machine. Let's call it machining center also. You know, 40 or 50% of the customers of Israel have at least one machining center in the factory. And we have 450 full 5-axis simultaneous package to those machines, to those users, those customers. We support Okuma, Mazak, DMG, Nakamura, Ermale, Doosan, Haas, all the type, UMC, Haas, UMC, 1000, 750, all the type, Grob machine, Makino. We have today a fantastic structure, VMID, fantastic ability of GPP tool, so we can do very fast any post-processor for any kind of 5-axis machine. This is very, very important. Let me see, I didn't forget something. Okay, let's jump to the part. This example, also, 5-axis part, not simultaneous. It's 2 plus 2, 3 plus 2, okay, positioning, we call it. But a lot of many operations needed here. And what is the challenges in this part? First of all, titanium. It's from titanium. So when I heard titanium, automatically, for me, it's iMachining. We use iMachining, no pocket, no other operation. iMachining automatically. Accuracy is important in this part. Mass production, 1,200 pieces, and the customer wants to finish it in one setup. Let's see. Okay. So we can see there is many operations here. We have spatial slot, let's say undercut slot inside that we will use spatial operation that we have in SolidCAM. But we start with iMachining. Look, iMachining, 20 millimeter, cutting length 20 millimeter, 12 millimeter tool, 27 millimeter pocket depth, wizard, automatically 2 down step. We don't need to do nothing. The level aggressive is 5, the feed weight come automatically. The system knows it's titanium, and easy to define. Let's see the results in Solid Verify. So we start with two face milling, 2 operational face milling, and we continue with iMachining. So what you see now is a rough cycle iMachining, yes, but the depth is in titanium is 13 millimeter. Yeah? In the conventional operation, maybe you can take in titanium 4 or 5 millimeter, and also the feed weight is fast, much faster, of course. So we can see from one side. Now we rotate the part 180 degrees and continue the iMachining for the second side. We will see it after it with machine simulation better. Now, specific operation for handle the T-slot, the hidden slot here. We have T-slot operation inside 2.5D. Very easy and very smart operation. You see the tool is penetrate to the hole and then widen the slot. We have spatial operation for it. You just need to define the geometry, define the ceiling face, the floor face, and that's it. You get the results. We continue to another very important operation inside SolidCAM, thread milling. We develop a spatial operation for thread milling, to support the thread milling of companies like Vargus or Carmex. Very easy. We need to define the position of the holes. We need to define the pitch of the thread and the number of flutes of the tool. And we get a tool pass, a helical tool pass with compensation, and we just need to say if you want to thread from bottom to top or top to bottom. You can see from few positions here. And our user, our customer, they use all those operations in daily use. Very easy and very strong. And again, HSS. Look how many fillets in this part. And also complex fillets. HSS is a fantastic module. We don't like boundaries. I'm not talking about boundaries. We don't like boundaries. In HSS, you don't need boundaries. You just need to click on the face, choose the upper curve, lower curve, and you get the result. Look how beautiful is the result. Very complex fillet here. Also go from bottom to the top and finish. No boundary, nothing. Okay, to the end, let's see the machine simulation of the entire part. So again, there. I'm machining. Now, in machine simulation, of course, we going to see the real picture. We can see this is the Ermale C22. We can see it's table machine. And now we can see exactly how it will be at the machine. Beautiful movement of the eye machining from two sides. Now it's very fast, so you can see it rotate all the time. You can see a drill, another drill. Now the last thing in this part, what we need to do, to disconnect, to detach the part, to cut the part, okay? So let's see how this user, how he did it. Okay, this is continue with the HSS a little bit. Okay, now we start to disconnect the part. He decided to disconnect the part from the back side, as you can see now, and to leave it in a thin chip that after it, we need to just to break the part and maybe to a little bit polish on the back side of the part. This is the advantage of using a high-end machine, high-end solution to finish any part in one setup. Okay, so what we use from SolidCAM? Which tool? Toolkit, T-slot and thread milling, very useful. Eye machining, of course, titanium. Positioning, 5-axis positioning. Full simulation, HSS. Angular head in SolidCAM. This is new. Maybe not for all, but it's new in SolidCAM now. Many customers need solution for this spatial tool. And we give them now, we give them a full solution, include machine simulation. Let's see. Part from our customer in the north of Israel. Not a complicated part, but very big. And you can understand that inside the part, we must use angular head in order to make the simple hole, but we must use an angular head. So the definition now is so simple. Inside the toolkit, we have fantastic option to it. We define the tool, standard tool. We define very easily the angular head. We use the same technology as 2.5D. We can choose any kind of operation from SolidCAM and use this tool. And we have what is important, that this is very big part. It's important to see a good simulation, not to make a crash. But we can see now we have machine simulation for it. We support the angular tool inside machine simulation. So you can sell now angular head to all your customers. inform them that we have solution to angular head tools. So we can see drilling all the holes with index, the part is rotate all the time, and now we can see a pocket with angular head. Okay, we continue. So, I want to summarize. So what are the sales benefit for us, for high-end solution? First, high-end solution that it's a market that grows from year to year, and we have a fantastic solution for it. So we must take advantage and leverage it. High price, for us, is a fantastic income. The investment is worthy, because for Swiss type, for milturn, for 5-axis, the customer needs to purchase most of our modules. Okay, so you understand that the price will be good, and the income for us is very good. Penetrating the customer, we use other CAM. We know that it's very difficult to change CAM system in a factory that use other CAM. But you need to show them some spatial, some unique feature. And now we have milturn, we have Swiss type. We can penetrate with Swiss type, with milturn, and after it, we will show them also the benefit they will get from iMachining and for other applications that we have. And last thing is subscription. I don't think the customer who have high-end solution of SolidCAM will take the risk to stay without subscription and maintenance. The chance that they will renew is high, so the investment is for long run. I think it's bringing me to the end. Thank you.
Thank you, Tzvika. Somebody asked a question.
Yes.
Somebody asked a question. Will the angular head be part of the new version, and will it be free?
Oh, nice questions. Let me think. No, the angular head is a module from now on, like all other modules in SolidCAM. The customer needs to purchase it. He will get a fantastic solution. So every customer that needs it, every reseller needs to order it from you, Linda.
Perfect.
Thank you.
Perfect.
Okay.
Thank you, Tzvika.
Thank you. Good luck. Oh.
All right, guys, we are here to talk about SolidCAM for operators. So SolidCAM for operators came out last year about this time when we were at our Israel summit, and didn't get a whole lot of traction as much as I thought we would. But so what I want to do is kind of go over the benefits of the SolidCAM for operators for you guys. So we were just watching Zika's part there, and there's a lot of operations there. But what if Zika programmed it a wrong feed rate? And now I'm down at the machine. I got nothing to do other than modify the G code, which I'll have to go back through and modify the program itself, or I can use my SolidCAM for operators. So what we're doing here is we are bridging the gap between the programmer and the machine operator. The programmer, let's say Zeke, I'm gonna pick on you, Zika, because you had those pretty parts and all. So all those programs, we decided to switch out end mills because the end mills were starting to go bad prematurely, and we need to adjust the feed and speeds. Well, now we can do that very simply right at the machine. There is no having to go back to that programmer's computer. There's no having to go up to the programming department. No trying to find out who programmed that part, because, you know, if I programmed a part, I don't want anybody else touching my program, right? So what we came out with is, like I said, an excellent bridge to bridge the gap between our operators that are on the floor as well as the programmers in the machine shop. So what we're looking at here is, on average, for the smaller shops, 1 to 3 CNCs, we have a 1-to-1 ratio, meaning that that programmer is also the operator for their machine. Now, if we get into a little bit larger shop from 4 to 10 CNCs, which is our red right there, we have 1 programmer for 2 operators. So now we start getting into a problem already, because one programmer for one operator works great, because when I have a problem on my machine, I can go yell at Zika and say, what were you thinking on this feed rate, guys? So now, into the larger machine shops, 4 operators to 1 programmer. Now, in the machine shop I came from, we had 100 CNC machines, and we had 5 programmers, all using SolidCAM. Here's the problem is, at our company, very large company, I had to walk my butt all the way upstairs just to do a simple program change. All of our shop computers are low-end shop computers that don't have SolidWorks, they don't have SolidCAM. So, what do we have for that now is our SolidCAM for operators. And Greg's gonna pass out some tablets right now. We are running a machine simulation on a sprayer nozzle using a tablet. A tablet. We're not worried about a big fancy computer anymore. Like I said, this is a small Surface Go that you guys can do your simulation on, you can do your verification on, all that stuff. Now, the big picture, or the big thing for the operators is the setup. So, as Zika's operations are there, you guys know as the operator, we're sitting there with our hand on feed hold, running that part through, cycle and through. Well, we can't see in that machine. We can't see on the backside. We can't see what's crashing or what's going to collide now, and this is what's going to prevent it. So we have the full ability to do the editor, simulator, and editor light. Now, why do we have the 3 different versions? Well, let's just say we have a new operator, and he's not very comfortable with the feeds and speeds, so I don't want him to give him the ability to modify feed rates. I don't want to give him the ability to modify toolpath. So I can limit them by using just the simulator only. So what's in the editor? So I can modify my operations. I can go in there and do simple modifications. I can make holes larger, smaller, whatever I need. I just cannot add new geometry. I can modify any geometry that's there, I just can't add new. I can change my toolkit. If I gotta swap out tools, I can switch out my feeds and speeds. I can change my coolant options, as well as a full simulation. Now, the editor light is gonna give you all of that, except we're not gonna be able to modify the geometry. So the operator will only have control over feed rate and spindle RPM and some coolant options, but we cannot physically change or modify the geometry itself, okay? Now, and our last one is, let's just say for our new setup guy or our new operator, is he's not able to make changes to the toolkit, he's not able to make changes to the geometry, but he is fully able to visualize the full toolpath in machine sim and part simulation and everything there, as well as full generation of the G-code. So, like I said, in a typical machine shop, if you guys have a machine shop that is 5 machines, even 4 machines or more, you gotta think we have 1 programmer for 5 guys. So this really bridges the gap between 1 guy trying to help 5 other guys out here. So this guy over here now, he can continue programming on all that new advanced stuff that's coming in the door, while the operators are able to make minor changes to get better parts in a faster cycle time for us, okay? So, like I said, having that tablet, what you guys are looking at right now, a Best Buy or a Walmart computer, I guess that's what we call it in the States, a very cheap computer. We do not need that powerhouse computer to run this, which is very important because in the machine shops, we do have those computers next to the machines, but those computers are for reading barcodes. It's for ordering tools or something like that. They don't have the capacity. But with putting this on there, we make that computer come alive now. All right, so some of the benefits. Tool damage. We can, like I said, as I'm sitting at that machine, I can visually see now without having to stick my head into the machine and worry about cutting my hands or anything, see how the crash detection is gonna work, as well as if I have any close calls in there. Now, working more efficiently. So if I got a program from Zika and he set me a feed rate of 50 inches a minute on my feeds, but I know I can do 75. I only got 12 parts to run though. Is it worth walking all the way up to Zeke and saying, hey, change that feed rate for a 5-minute time savings? Or we can do it right on the operator. So I can easily make those fine-tuned changes right on the fly very quickly and easily now. As well as we got a full setup picture. I can generate a tool list. I can see the tools that are in there. I can see the flutes that are in there. I can see the barcodes on my tools. So the setup time will go much faster because if you think about it before, when our SolidCAM program came up, we had a setup sheet and we had a NC program. These are our two things. Well, I can put my tools in there, I load the program in there, I have no idea where that spindle's gonna be going unless I wanna read through the entire G-code, where if I go up on my simulator, hit play real quick, boom, I can easily see or see what's going on or what's gonna be going on in that machine instead of wasting time. Feed, hold, single step, single step, single step, okay? Now, big one, eliminate those dry runs. We all do dry runs. We don't want to get in the machine and all of a sudden we get that certain point and oh boy, you gotta pucker up a little bit and that's getting really close. So we don't even have to do the dry runs anymore. As long as we got our good TLOs and our work offsets, cycle start, go. Now that we have the operators, we have our computer right by there, any modified geometries, right on the fly, go for you guys. Okay? So, my thing to you guys is SolidCAM for operators, every shop that has 4 machines or more should be a must. For you guys, the sales guys, this is a huge benefit for you guys because you guys can say that you're basically getting a second seat of software for 1/10 of the price. We got 5-axis that they're running up on the office, and we got the simulator down here. The simulator costs nothing compared to the 5-axis, but I'm still able to do everything with the operator that the big programmer up there can do other than modify my geometry, okay? All right, and we do have a video. Happy operator.
Now you see why every machine shop using SolidCAM need the operator. Priyanka now is going to tell us how having this tool helped her sell SolidCAM, full SolidCAM, and replace a competitor software.
Hello. Yeah.
Just 1 minute.
Yes.
After, this is your last presentation. This is the last presentation. No.
Anuj sir. Yeah.
Oh, okay.
Well, good evening all. We have seen here the presentation by Kevin. I have a real example that how SolidCAM for operator helped us to win the SolidCAM deal against the competitor CAM. Well, we all know this is the real problem at manufacturing industry. And one of our prospect when we have visited, at that time we have also seen the same situation. And this customer is one of the leading manufacturer of jigs and fixture for the automotive industry, along with that aerospace industry and defense industry. So when we have shown this amazing product, he changed his mind. He replaced all his competitor CAM, and we have sold the multiple licenses of the SolidCAM over there. So this was, I really thank to Kevin and team and developers for introducing such a wonderful product, because you said rightly that this is the bridge between the operator and the programmer. So existing SolidCAM or existing customer has around 25 licenses of the SolidWorks and 4 licenses of the MasterCAM, where along with the seamless integration, we have given the wonderful solution to him that is nothing but the SolidCAM for operator. He is really impressed and he completely replaced MasterCAM with SolidCAM. So thank you to the team, and this was the real example I wanted to share with you. Thank you.
Now comes our last lecture. He has 20 minutes. Then we go to the board.
Hi. I know I need to rush. So, Anuj Bhandari, I'm handling sales for India and the Middle East region. So, to cut short, my topic is incorporating technical people into sales. I can promise you, or I will try my level best after watching this PPT, you can see the methodology, what we follow, and I can promise that you won't have the problems of generating high quality leads. I will try. So, okay, something about SolidCAM India, a team of 66 people, offices in different locations. Let's skip that, but if you can see, 66 people, and out of which I think sales are only 30. So what about the rest of the people? So what I believe, whosoever joins SolidCAM is a sales guy. No one in the company can say I'm not a sales guy. Even the accounts guy, the documentation guy, or the person, because he is helping the sales guy in some direct or indirect manner. So everybody is a sales guy. Salesperson, not guy, salesperson. Okay. Certain techniques to generate leads. I have discussed yesterday, but these are very important points. We get leads through our existing clients, through our existing SolidCAM users, through technology partners, through SolidCAM internal technical team. That's the main focus for this presentation, technical team. I'll discuss on that. Through resellers, through seminars and exhibitions, through education sector, through advanced CNC machine sector like Swiss type machines, multi-axis machines, through SolidCAM Technology Center, through social media, and through open house events. Okay. Now, how do we groom a technical person into sales? How does a technical guy becomes a sales guy? See, we need to have backup. We need to have the main army and the main army and the sleeping army. So the technical guys, active or passive, salespeople. So, okay, incorporating technical people into sales. Why? Why do we have to involve the technical people into sales? Let's see. Technical team is closest to any existing client. They are the closers, not the sales guy. Sales guy would sell and he would be gone. He would be coming back after 1 year. But technical people are in touch. Technical people knows the client new requirement. It could be an add-on module, new license. Technical people can create a new requirement. They can study the machine, the application, number of operators, programmers, etc. And if support is good, your subscription becomes very easy. So these are the basic 4 points. I wanted to discuss these 4 points in detail, but because of short of time, so let's move forward. Now, what are the advantages of involving technical people in sales? Number one, lead generation could be doubled. When I say doubled, I will show you how we double, at least in India, and it works in India. And it should work in other parts of the world, I think. Sales could be doubled. Network could be doubled, because when I said we have 65 people and 13 sales people, so the rest of the team, if they interact with the network around India or across the globe, your network could be doubled. I'll show you some statistics. And technical people to become techno-commercial conversion. You know, I've tried my level best to hire a fresher, a mediocre, or an expert coming from some other industry and groom them on SolidCAM. Frankly, it's very difficult. The easy way is groom your technical people to become a techno-commercial person. And a techno-commercial person is the best person, what I believe. Some statistics. If you can see, this is some comparison between the number of regions we have in India. Column number 3 reflects the number of salesperson per region. Like, for example, in Punjab, we have 2, Delhi, we have 4. So total team of 13 salespeople. And column number 6, you can see the number of technical guys who are directly involved with the software, post-sales and pre-sales. So 13 salespeople are able to generate a rough number of 130 leads per month. Let's imagine one sales guy generate 10 leads in a month. So 13 into 10, 130. And 28 technical guy, we give them a target of generating 5 leads in a month. It's very easy. Let's see. So 5 multiplied by 28, 140 leads generated by technical people. So total you can see 130 plus 140, 270 leads per month. And this happens, frankly. So let's see how. How do we do this? 2 components, planning and motivation. And like yesterday also I said, motivation is the main key factor. You need to motivate the technical guy. Sales guy, it's their responsibility to bring sales, but there is no responsibility of a technical guy to bring sales. So you need to motivate them. So how do we motivate them? We incentivize them. We give them incentives. It's like recognition incentives. It's like the financial incentives. So we have 3 types of incentives. Leads incentive, sales incentive, and target achievement incentive. So we need to discuss this very fast and just see the statement. Sales incentive for technical engineers. This is something not heard of, but yes, it works. So the first type of incentive was lead incentive. So I would like to give an example. A salesperson, these figures are for India. In your respective country, you can change the numbers or the incentives, what you could give. So in India, an approximate value of 10 leads, if somebody brings a technical or a sales guy, he gets an incentive of $50. This is for technical, by the way. And we have 28 technical guys. So just imagine 28 multiplied by 10 corresponds to 280 leads per month, and we need to spend $1,400. It's like spending $5 per lead. And mind it, these leads are very, very qualified leads, because if you're getting leads from social media or from some third-party companies, there could be some junk leads coming up. You'll be filtering 1,000 leads and coming down to 10 leads. But these leads are coming from your own engineers. They cannot bluff you, because we have a record and we believe in our technical engineers. Okay. The first incentive. The second type of incentive is sales incentive for technical people. This is, let's see an example how it works. For example, if a technical engineer who has brought 10 leads, and out of 10 leads, one of them gets closed. So he gets, so So what we do, we calculate 3% of the incentive. So 3% of 10,000 corresponds to $300, and this $300 gets divided between the sales guy and the technical guy. I'm not asking the technical guy to bring a lead and to close a lead. No, the lead has to be passed to the sales guy, and the sales guy and the technical guy, they work together. So the incentive gets divided between two. So this was second kind of incentive. The third incentive was if a technical guy accepts a challenge of, now for example, one of my technical guys accepted a challenge for bringing $15,000 in a quarter. So I promised him, you'll be getting $100 every month if you achieve that target. So in short, let's see the total incentives, what a person can achieve. Lead incentive, $50, sales incentive, $150, target incentive, $100. And for example, the person has a salary of $800. So let's see the cumulative thing. 800 plus 50 plus 150 plus 100. So close to $1,100. So it's like 37% increase in his salary. This guy would take 2 years to achieve this salary because it's like 37%. You don't increase 37% in 1 year. It's like 15%, 20% in 1 year. So every technical person can earn a salary which he would earn maybe after 2 years. So it's like motivating them. Next, how do we do this? Okay, the motivation part was done. Now let's see the planning part. You need to motivate them, but now you need to teach them. It's not, okay, they are motivated. Now what do they do? They say, okay, we are very happy, but we don't know what to do. So let's see. Okay, the first thing is you need to teach them how to generate lead. Every sale start with a lead. You don't have leads, you will be always like, okay, my region is not working because I don't have leads. You know, let me give you an example of South India. My colleague, Mr. Arun Kumar, he's an expert on sales. I closed a deal for $10,000. He has a capability to close the same lead at $15,000. His problem was leads. Every time he used to tell me, Anuj, you are lucky. God has given you something, you are lucky. You remember, sir? Now, we have followed this methodology, and he has so many leads, and when we ask him, have you evaluated the leads? He says, no, I have scarcity of salespeople now. So now the problem has changed from not getting the leads. The problem is now level number 2. Now, he tried his level best, but for some reason, we are not able to find salespeople. Then he started grooming his technical guys on sales. And I think he is the only guy in South India. We have freshers, but he is achieving his targets 120% every quarter, almost. So his technical team is now bringing sales. If I'm not wrong, sir? Okay. So I could have some plus points. He could have some plus points. We need to mix and match everybody's good points. Okay. We have 4 steps how to generate lead. The first is through our existing client. Through existing client, you need to teach your technical staff, technical team that you can get leads from your existing clients. Existing clients itself is a lead. You can give subscription, you can give add-on modules, you can give an additional license. I consider this also as a lead, and we pay them for this lead because people forget that you can sell an additional license to your existing client. And why? The reasons are simple. I already discussed these 4 reasons. That technical guy is very close to the client. He knows the client's requirement. He can create a new lead. So the same points. Okay. Second point is through existing SolidCAM users. So what do I mean with that? You can get information from the users, people who are using SolidCAM. They have friend circle, and they must be having the contacts of other software CAM users like DellCAM, MasterCAM, etc., etc. So what you need to do, you need to teach your technical people to make a list of 100 not on SolidCAM users, 100 users who are working on different CAM software. Now, how do we do that? Every technical guy has to be in touch with 20 SolidCAM users and ask them to give only 5 contacts. So one guy gives 5 contacts for other CAM software. So 5 into 20 becomes 100 users which are not working on SolidCAM. So invite them, these people in your office, in the events, what you plan, provide them with the demo version at home or the company. Teach your team how to provide them demo version, how to contact them, how to invite them in your office. Provide them online basic training, group training, give them free software. And add them on WhatsApp, on social media, LinkedIn, whatever benchmarks you do, show them you are doing, you are very active on the group. And I'm sure if one guy is handling hundreds of people not working on SolidCAM, I'm sure within a span of 1 year, minimum 20 people would come back. Okay, I'm interested in SolidCAM, or they will migrate to some other company, and they will call you, I need SolidCAM. Okay, this is very interesting. Generate lead through technology partners. Machine partners like Mazak, Ace, UCAM, Mitsubishi. Through cutting tool partners like Mitsubishi, Motherson. Through our reseller, Cadwin, Reliable, Spinac. By the way, these people they are available right now, so intentionally I have mentioned few names. And what you are supposed to do, you are supposed to provide them with partner licenses. You are supposed to, their technical team is supposed to provide them partner license. Technical team has to take the responsibility of training them. Technical team has to do benchmarks for them so that their machines could be sold. Help Mazak, help UCAM to sell their machines, because when they are selling their machines, automatically your product would go. And in the last, provide them leads. You can provide them leads to sell machine. You have thousands of customers. Just be in touch with the customer when he is going to buy a new machine and inform your partner. It's like an ecosystem of SolidCAM, Mazak, Ace, UCAM. Now, we are very thankful to our partners. We have 4 partners right now with us right now sitting in this summit. We have the first one, okay, from Mazak, India, Mr. Rajiv Pundir. He's the technical head for North India. And by the way, this gentleman, we approached him in the year 2010, and everybody was approaching Mazak. Okay, go for HSM, Delcam, blah, blah, blah. So we said, we are a very serious player. He said, okay, everybody says you are serious. So we installed the software, we provided them training, and it took 2 years to convince us, because whenever they had the problem, we were the first guys who said, okay, we are ready to come with you and do the benchmark. So it's been a very difficult process, but now it's very strong. This guy works on SolidCAM like anything. I mean, his capability sometimes exceeds our technical guys. So, by the way, there are 2 types of partners, direct and indirect. Because Mazak or some other machine vendor could have some privacy on their data. So they don't tell us that, okay, I'm going for a benchmark, this is the customer name. No. We support them without asking the names. He goes, he cuts the part, or he takes help, he takes our engineer. We never ask them what is the name of the customer. And indirectly, after 6 months, 2 months, 3 months, we get a call from the customer. We contacted Mazak. Mazak said, I am using SolidCAM. So it's like an indirect type of selling with Mazak. The second is Ace Micromatic, Mr. Arjun. He is also sitting there. So, thanks, Arjun. They have an installation base of 70,000 machines in India. They have the biggest machine tool builder in India, selling 7,000 machines in 1 month. 1 year, sorry. So, by the way, they have their offices located all across India. So every month we have a meeting with them. They collect data from their regional offices and provide us leads. Frankly, they have provided us so many leads, and now we are scared of them. We don't want to face them, that what has happened. We don't have salespeople, sufficient salespeople to handle their leads. The third one is, okay, we have somebody from Middle East also, because we are handling Middle East. Philips Machine Tools, Middle East, Mr. Jopu. So, yeah, they are one of our best resellers, partners, friends in the territory of Middle East. We started Middle East just 1.5 years ago, but we were lucky to have them. And just a very small statistics that we closed, last year we closed a number. It was a learning stage for us, and this year, the first quarter, Philips touched their number for the entire year. So they're bringing us very good sales. And not only Middle East, they have their presence even in African markets. So North Africa, Egypt, Kenya. So they are helping us to expand in different regions. The last one is UCAM India. Yes, VCAM, and yes, UCAM. The name of the company is UCAM. Mr. Vijay is the sales head for UCAM, and UCAM is the #1 rotary machine, an additional 4th axis, 5th axis machines, which is added on your existing, it could be added on your existing 3-axis machines. They have an installation base of 10,000 clients, and now we are in touch with them for the past 2 years, and we are now in discussion to work together, and Mr. Vijay has given us very good suggestion that why don't you add the 3D model of the UCAM rotary machine in your software. It's like a library, making the fixture like Daniel was showing. So we have a target now to maybe target, if he would permit, these 10,000 customers and growing and growing. So now you can see we have problem of not going to a lead. We have hundreds, thousands of leads. Now the problem is level number 2. How do we get salespeople to monitor these leads? So now we need to teach them. We need to teach our resellers, our partners, how to sell. Like Philips, I mentioned the Middle East reseller. Mr. Jopu has a technical team, and now they are well trained on SolidCAM. So most of the work is done by them. We do only the fine tuning. Okay. One sec. Okay, we also have our 3 resellers, Cadwin, Reliable, and Spinac. They are one of our founding, the key players in the Indian industry. So, because we are short of time, I'll skip few of the, okay. This technical team should go to their, if a country has a technology center, SolidCAM technology center, they should conduct open house events with the partner. It should be the responsibility of the technical team. They should invite the existing clients, users, do joint technology with technology partners. They should do this open house event for other CAM software users, etc. I'll skip a few of the slides. And now, in the end, I should say stop the struggle, the lady says, and continuous implementation of the above activity could generate leads, motivate your technical team, generate new sales engineers, in-house generation of new sales engineers, that techno-commercial person, and increase the sale. Thank you.
Thank you, Anuj.
Yeah.
The bus will leave at 6:10. They'll be at the entrance to go to the boat. Please be here at 6:10. Thank you. The entrance at 6:10, not here. Thank you.